Hello guys, welcome to this exciting journey into the pattern recognition. In this video, we will explore the fundamentals of how machines identify the patterns and make decisions. Pattern recognition is the backbone of the AI, machine learning and the computer vision, enabling the applications like the face recognition and handwriting analysis. We will cover the various classification techniques, estimation methods and clustering algorithms used in this field, from Bayesian's decision theory to neural networks. The subject offers a deep dive into the machine intelligence. We will also explore the dimension reduction methods like the PCA and the feature discriminant analysis. Advanced topics like the hidden Markov models for sequential pattern classification will also be discussed. By the end of this course, you will have a solid foundation in pattern recognition techniques used in the real world applications. So, if you are interested in AI, machine learning, or computer vision, this subject is a must learn. Let's begin our journey into the fascinating world of pattern recognition. So, introduction to pattern recognition. Pattern recognition is the process of identifying and classifying the patterns in the data. It is widely used in the image processing, speech recognition, and medical diagnosis. The goal is to train machines to recognize the patterns, just like humans do. It can be broadly classified into supervised, unsupervised, and semi-supervised learning. Supervised learning uses the labeled data, while unsupervised learning deals with unlabeled data for clustering and pattern discovery. Here, labeled data means what? Labeled data means yes, no, means the types of the outputs, like you can say the weather will be hot, rainy, sunny, etc. Means there is a, you can say, class labels, but clusterings, the groupings, the data belongs to which clusters or not. Okay, so feature extraction plays a crucial role in pattern recognition. Some common techniques like the decision tree, neural networks, and Bayesian classifier helping in reducing the complexities of the models. Applications ranges from fingerprint identification to recommendation systems. With the growth of AI, the demand of pattern recognition is increasing rapidly. In this course, we will learn how to develop intelligent systems that can identify the complex pattern efficiently. So, Bayesian decision theory. So, this is a fundamental statistical approach used in classification problems. It provides a framework for making the decisions based on probabilities and prior knowledge. The main components include the classifier, discriminant functions, and decision surfaces. A classifier assigns an input pattern to the most probable class based on observed data. Discriminant functions help to differentiate between the classes, while decision surface determine the boundaries between them. The normal density function is commonly used to model the data distribution in the Bayesian classification. When dealing with discrete features, probability mass function are used instead. You already know from the engineering mathematics probability sections. So this method is widely applied in the medical diagnosis, spam filtering, and speech recognition. The Bayesian approach is robust as it combines prior information with observed data for better decision making. So now, parameter estimation methods. Parameter estimation is essential for constructing the probabilistic models in the pattern recognition. The maximum likelihood estimations method is commonly used to find the best fit parameters for the given dataset. So, Gaussian mixture model is another widely used approach for modeling the complex distribution of data. The exception maximization algorithm is used to estimate the parameters when the data has missing or hidden variables. Bayesian estimation goes a step further by incorporating the prior knowledge into parameter estimation. These methods are crucial in speech recognition, biometric authentication, and NLP. Accurate parameter estimation improves the efficiency and reliability of classification models. Learning these techniques helps in building better machine learning models with higher accuracy. So now, hidden Markov models for sequential pattern classification. So, hidden Markov model are used for sequential data classification like text data, such as speech and handwritten recognition. Hidden Markov models are based on probabilistic state transition, where the systems moves between the hidden states based on probabilities. There are two types: discrete HMM and continuous density Markov models. So the three fundamental problems of hidden Markov models are evaluation, decoding, and learning. The Viterbi algorithm is commonly used to find the best state sequence for given observations. Hidden Markov models are widely applied in the NLP section, stock market analysis, and bioinformatics. Understanding the hidden Markov model enables us to work with real world time series and sequential data effectively. So, dimension reduction method. Dimension reduction helps in improving the model performance by removing the redundant features. Two widely used methods are principal component analysis and feature discriminant analysis (FDA). So PC reduce the dimension by transforming the data into a new coordinate systems where the variance is maximized along the principal component. So this techniques helps in handling the high dimensional datasets, making models more efficient and interpretable. Dimension reduction is essential in image compression, text analysis, and bioinformatics. Reducing the number of features also helps in avoiding the overfitting problems in the machine learning. By using these techniques, we can improve the computational efficiency while also preserving the critical information. So, non-parametric estimation methods. Non-parametric estimation methods do not assume any specific probability distribution for data. One of the most commonly used techniques is Parsen window method, which estimates the probability density by placing a small window around each data point. The k-nearest neighbor method classifies a new point based on the majority class among its nearest neighbors. These methods are flexible and work well when little prior knowledge about the data distribution is available. Unlike the parametric method, non-parametric techniques require a large amount of training data for accurate classification. They are widely used in image recognition, medical diagnosis, and document classification. The main drawback is their computational complexity, as they require storing and searching through large datasets. However, advanced indexing techniques can improve their efficiency, so these methods are useful for problems where data distribution is complex and unknown. Linear discriminant function based classifier. Linear discriminant functions separate the classes by a linear decision boundary. The perceptron algorithm is one of the earliest linear classifier used for binary classification. It updates the weights iteratively to find an optimal decision boundary. Another powerful technique is support vector machines, which finds the best hyperplane that maximize the margin between the classes. SVMs can also handle the nonlinear data using kernel function. Linear classifiers are efficient and work well when the data is linearly separable. However, they struggle with complex patterns that require the nonlinear decision boundaries. These classifiers are widely used in face detection, spam filtering, and text classification. Learning about these methods helps in understanding how machines make decisions based on feature space separation. Features here, the characteristics of the objects or the data, or you can say the columns. Okay. Non-metric methods for pattern classification. Non-metric classification methods deal with nominal data. Nominal means non-numeric, where traditional mathematical models do not work. A popular non-metric classifier is decision tree, which recursively splits the data based on feature values. Decision tree are easy to interpret but widely used in business intelligence, medical diagnosis, and fraud detection. They can handle both numerical and categorical data without requiring the complex transformations. The major challenge is overfitting, which can be mitigated using the pruning techniques. Decision trees form the basics of powerful ensemble methods like the random forest and gradient boosting. So, at first you need to learn about decision tree, then you can learn gradient boosting or random forest, etc. topics. So, non-metric methods are useful when dealing with symbolic, qualitative, or you can say the structured data. Their main advantage is their interpretability and flexibility in handling the diverse data types. So, unsupervised learning helps in discovering the patterns in the unlabeled data. Clustering is one of the key techniques in unsupervised learning where similar data points are grouped together. So, a common approach is the k-means algorithm, which partitions the data into k clusters based on feature similarity. Hierarchical clustering creates a tree-like structure of clusters useful for text mining and bioinformatics. Other clustering techniques include DB-scan, mean shift, and Gaussian mixture models. Clustering is widely used in customer segmentation, anomaly detection, and image compression. Choosing the right clustering algorithms depends on the data distribution and the number of clusters. Understanding these methods is crucial for discovering the hidden patterns and trends in the large datasets. So, let's conclude our introduction to pattern recognition. We explored its fundamental key classification techniques, real world applications from Bayesian decision theory to hidden Markov models and clustering techniques, etc. So this field plays a vital role in the AI and machine learning. We also touched upon dimension reduction, clustering, estimation methods. Understanding this concept will help you to develop powerful machine learning models. In the upcoming videos, we will dive deeper into each topic with detailed explanation and examples. Stay tuned as we explore pattern recognition step by step to build a strong foundation. Make sure to like, share and subscribe if you found this useful. So don't forget to drop your question in the comments. So we will be happy to help you. See you in the next video where we begin with chapter 1, Introduction to Pattern Recognition.